Welcome back. We're continuing our investigation of the third problem for 3.7 growth rate. We're currently looking at what's going to happen as the population of a little town gets bigger and bigger and bigger when its water supply is only designed for 30,000 people. The first thing we want to do is write a function that closely matches the data for the x values for the years 1, 2, 3, 4, 5, etc., saying that year 0 is year 2007. So to write a function, we have to get a picture. And when we used our graphing feature to get a picture, we noticed this actually looks highly linear. So we're going to use a linear model. And a linear model needs a slope and a y-intercept. Now, the y-intercept is always the value when y is 0. So that's going to be 15,000. The slope is the change in y over the change in x, or the change in population over change in time. So the change in population in the year 2012 was 18,250 minus the 15,000 people who were there to begin with, all divided by 5 years that have gone by. So that means our slope should be about 650. So our model is going to be equal to 650 times the year since 2007 plus 15,000. We then pull down our model so we can compare with it directly. And we notice that it's actually pretty close. In fact, if I modify this chart so that includes the new column, or E9, and then let's put this away. Let's see. Do we see it there? And as you can see that in our series, we have E4 to E9 and D4 to D9. And we want to compare the two. Looking back at our graph, do you see how they're almost sitting on top of each other? So much so that you can't even see the other. Let's look at the next question. So we have our function right there. Assume the function is good for the model for 2012 to 2032. At what year during that time frame will the water supply run out? So having now designed this, we can move our model out of the way over here. I can then extend the years down to, let's run it down to, I have to select more than one so I can see the pattern I wanted to copy. Extend it down to, there we go, there's 32. And then I can take my model and I can stretch my model all the way down. And right about 2031 is where the population goes past 30,000. So our model would predict in 2030 is when you're going to have the maximum number of people that the water supply can support. At that point, either you want to build a larger water supply or you want to build somewhere else. Hope this was helpful to you guys. I'll see you guys on Monday. Have a wonderful rest of your day.